I don't know how you could keep walking after seeing APL. I mean, for me, it it was the character set. It's so beautiful. APL is just beautiful. Steven, you know what I'm talking about, right? It's a beautiful, you know, uh, I, yeah. I think a certain number of us, including Arthur Whitney, I won't have APL character set envy.
Welcome to another episode of Arraycast. I'm your host, Connor, and today we have a special guest who I am super excited to interview. But before we get to introducing him, we're going to go around and do brief introductions, and then we've got a short announcement from Adam. So first we'll go to Bob, then to Steven, and then to Adam.
I'm Bob Terrio, and I am a J enthusiast, currently working on the J Wiki. At least I should be. I've sort of been working on another project for a bit, but I'm going to be back at it soon, and we're making progress with it, and it's a lot of fun. And if you're interested in being sort of on the ground floor of building something, the J Wiki is a really good place to be right now.
I'm Steven Taylor. I'm an APLer from way back, and these days I do most of my coding in Q, and I'm the KX librarian.
I'm Adam Blutzewski, an APLer from not so far back, full-time for Dialogue. And I guess I can, in that connection, say that on Thursday and Friday, the 5th and 6th of May, both the Finnish user group and the German user group are having their spring meetings, and we'll have links in the show notes to those. You can sign up for those. They can both be attended in person and at least partially online as well.
Awesome. So yeah, we'll have links for that in the show notes of all of our episodes, as usual. And last but not least, I'm your host, Connor. I'm a professional C++ developer, but I'm a huge array language enthusiast and combinator enthusiast at large. And super excited to talk to our guest today, who actually kind of shares the same name as one of our panelists, a different spelling. But so we have Steven Taylor, who's our panelist, and our guest today is Stevan Apter. And I will do a brief introduction because I actually know much less about Stevan Apter than our other panelist, Steven Taylor, knows, because I think they've known each other for quite some time. I first came across Stevan Apter's name, or more accurately, his website, which was www.nsl.com, which when I stumbled across this website, I sort of fell off my chair because NSL stands for No Stinking Loops. And any of our C++ programmers will know why this is sort of funny, because in the C++ community, there is a sort of famous quote for some definition of the word famous called no raw loops, which was popularized by Sean Parent, who works at Adobe. And so that's sort of like an aphorism or a witticism that exists in the C++ community. And I actually bought the domain to norawloops.com. And so when I stumbled across this, I was like, what? Like, I was falling in love with array languages, and then came across another website that exists, and they just were one word different. Anyways, on this website are a ton of different links, some of them to projects, some of them to YouTube videos, some of them to different websites, mostly focusing around K, the different variants, K3 all the way up to K9. And yeah, Stevan Apter, I've heard his name both from Steven Taylor and from Arthur Whitney, has done a ton of work around the K language, currently works at 1010data.com, which I think he'll tell us a little bit about more later. But with that said, I'll throw it to Steven Taylor, who can give a sort of more in-depth introduction than I can.
Oh, I don't know that this is going to be more in depth, but let me take you back to the very first Batman movie, the one with Michael Keaton and Jack Nicholson, because Steven is definitely an eminent figure in the array programming community in the Iversonian languages, and there's a moment of wonder in that Batman movie where Jack Nicholson's character, the Joker, just stares at whatever it is that Batman's doing. He says, where does he get all those wonderful toys? And Steven's code kind of evokes that reaction from people reading his stuff. How does he think of these things? How could he possibly know that would work? So I'm excited to have him as our guest here on the show today, and I'm hoping to learn a lot more about K than I've ever known. And I'm particularly interested in the relationship between Q, which I do use, and K, which I don't.
So with that, I think we'll throw it now to you, Stevan Apter. Feel free to jump back as far as you want to go and give us the brief history of Stevan Apter from anything you'd want to share with us.
Well, thank you. First of all, thank you to all of you for inviting me, and thanks for that wonderful introduction. So now I'll disappoint everybody by revealing the truth, the actual truth. Let's see, brief biography. I was a fine arts major in college. I had a teacher advisor who said, why are you wasting your time with paint and canvas? Why don't you go learn some programming and you can do some interesting work with EAT at MIT. So I dropped out of college. I went to Control Data Institute. Some of you may remember this vocational school started up by Control Data Corporation. And I spent 10 months learning how to program in RPG and BAL captured my imagination. I took a job with National Science Foundation as a computer programmer / operator aboard an Antarctic research vessel. And spent 2 years in the Antarctic programming and babysitting an IBM 1130, a wonderful machine. And in the course of that employment, I learned APL. We had an APL interpreter, APL 1130, and that was fascinating. So after that stint, I went back to college and spent some time, including several years as a graduate student at Princeton in the philosophy department, and then returned to programming. And was fortunate enough to secure an APL job with Harcourt Brace Jovanovich in their management sciences / OR operations research department. And again, that was a wonderful experience because it taught me something about business, which I didn't know anything about it, how businesses operate. And I had a wonderful advisor was an alumnus of Institute for Advanced Studies, a colleague of Nash, actually. His name is Carl Heimowitz. And Carl, again, taught me the difference between theory and practice, something I needed to learn after 4 or 5 years in philosophy. And I made my living thereafter as an APL programmer until meeting Arthur Whitney at Morgan Stanley, where he had developed A+. And I worked with Arthur, got to know him, and it was a significant event in my life, since Arthur taught me how to look at programming, how to think about it, and of course, Arthur has, apart from his incredible skills as an implementer and designer, tremendously fertile imagination. Arthur has insights into the nature of algorithms and programming languages that I think those insights are unique. But I particularly it was rather his ideas about what you could throw away, what you didn't require. So coming from APL, especially APL2 and Sharp APL, which seemed to me to represent the best solutions to the problems that APL 360, the limitations of APL 360. Arthur had this remarkable insight that there were other ways to enhance the power of APL 360. So he we talk about that some other time. I'm not even sure I'm the best person to talk about it. So, so then I became, I guess, an itinerant K programmer. Yes, K. Um, when Arthur left Morgan Stanley to form Atlantis Software to develop the first version of K, we stayed on at Morgan, and eventually joined him. A group of us joined him at UBS, where what we now know of as K3, or the last version of that idiom, that dialect of K, was developed. And we had 2 or 3 years at UBS where we had a captive audience. We had the entire American branch of UBS. Our CTO was David Weiss. The head of the fixed income was Joel Kaplan. And so we had a chance to not just develop the language, but a kind of a laboratory of like application opportunities. And that was fascinating. And that it was there that I wrote UBS used Sybase extensively. And as you know, the K3 doesn't have the database primitives, select and join and things like that. So one of my tasks there was to develop the first version of what I guess KDB. But it wasn't KDB. It was an attempt to exactly duplicate SQL 92. And that was fun. So from there, after UBS, various jobs in finance industry, and now currently for the last 6 or 7 years, I've been working at 1010 Data, which is where we do basically big data applications for various domains. And so that's the biography. I hope that didn't take up too much time.
Wow. No, so this is like similar to when there's a couple guests where this has happened. I think Eric Iverson was one of them, where like that was like that was so amazing. I was like, that's like better than like watching Marvel movies for me, is hearing about which maybe doesn't make sense.
Seems very prosaic to me. I mean, of course, I lived it.
I mean, so you start with I was a fine arts major, and already I'm like, wait, what? Okay, didn't expect this. And then you talk about how you had a professor. I'm not sure if that was an actual fine arts professor or was a different professor that encouraged you.
Yeah, it was a fellow from MIT who had been using computers to design sculpture. In fact, it's really kind of interesting when I went to Control Data Institute, which was I think it's marvelous. I'm a huge fan of vocational schools and vocational training. I think for some people at all talent and intelligence levels, vocational school is just a wonderful thing where you go to learn a very narrow, well-defined set of skills, very practical set of skills. And so the teachers they hired at Control Data Institute were all professional programmers. Now remember, this is 1969. I mean, there weren't that many programmers around, and some of them were like veterans. We were introduced to wiring plug boards on card sorting machines. Terrific stuff. And the first language we learned was RPG. Do you remember RPG, Report Program Generator? It was designed to do I don't want to say it was declarative language, but you wouldn't recognize it as an algorithmic programming language. So it was like a primitive kind of COBOL. And my first application in RPG was designing geometrical patterns for 3-dimensional sculpture. It was great. It's probably set the pattern for my life as a programmer.
Yeah, I think we'll have to find the link to the Wikipedia page for RPG. I've been told about it once, and I looked into it, and it reminded me of yeah, I can't remember, sort of those COBOL, like all of the screens you see of it, it looks like it's on some DOS box, or what I think of as a DOS box, which actually used to be a DOS computer at one point, but they don't
Yeah.
make those anymore. Anyway, so yeah, we could. I feel like I have 1,000 questions, but I'll pause and wait my turn, because I feel like unless if no one else has one ready to go, then I'll just go ahead.
I just think it's amazing that somebody starts out their bio with, and then I went to Antarctica and spent a year on a research vessel programming an IBM 1130. It's like, oh yeah, that happens. It's like talking to the world's most interesting man.
So how many? Yeah, I guess my first question is, how many languages? You said, I think RPG, BAL, and then you discovered APL. Were there any other languages in between the ones you first picked up and then before you got to APL?
Yeah, I mean, Control Data Institute was, remember, it was a 10 months, 5 days a week, 8 hours a day. And so the course consisted of RPG, COBOL, PL1, um, BAL, Snowball, on both IBM 360. There's a little 4K 360/20 machine on the premises, and then there was time sharing with CDC's 3300 and 6600 machines, which are very unusual, very fast machines for the time, very powerful. So it was a good kind of sampling. And of course, most of the people in the program were older, um, and had come from other careers. There were secretaries, there were truck drivers, people who had kind of read the advertisement on the back of the matchbook cover, learn computer programming, and they went on to COBOL, mainly I think COBOL jobs for firms like Prudential Insurance and so forth. And when I was at sea, for National Science Foundation, it was a um, Fortran and 1130 assembler and APL. There was an APL application for doing satellite navigation.
Interesting. And so how did when you end up on a boat in Antarctica, for I'm guessing it was a large boat?
Not that big. It was an icebreaker. I guess not sure how many tons it was, but yeah, I think there were 60 scientists and maybe 80 or 90 a merchant crew running the boat. That could be, I could be off by some fraction, but yeah. Oh, sorry. I'm interrupted you. Please.
No. This, like I said, this is like I'm playing a real life video game, and just like yeah, it's great. And so I'm curious. Do they have, like, how did you? It sounds like you had to pick up Fortran and APL, and then when you were sort of going through the brief history, you said, this is interesting. Like, what? I'm always curious as to, what is it for the folks that end up falling down the array language rabbit hole, that they've learned a plethora of languages or a handful of languages, and then they stumble. Usually, it's onto APL first because that was what existed first, and it just completely ensnares certain people. And I'm always trying to figure out, what is it that that happens to certain people that other folks, they just see it and they sort of keep walking because they're that looks weird.
I don't know how you could keep walking after seeing APL. I mean, for me, it was the character set. It's so beautiful. APL is just beautiful. Steven, you know what I'm talking about, right? It's a beautiful, uh, I, yeah. I think a certain number of us, including Arthur Whitney, I won't have a APL character set envy. you know, is it superficial? Are these superficial characteristics? What do you think? What do you think? Do you think the physical appearance, the physical beauty of the type of the font, and the way operations connect up, and do you think that's superficial? Am I being shallow here? Should I be talking about the profound, the nature of arrays, and how the tools of thought and all that? Oh, that's just a beautiful language, and that's what got me.
Stephen Taylor?
There's a four-letter word which comes up quite often in talking about computer science, and it's cool. And the reason I mention it is that within this field, within this domain of discussion, we don't generally acknowledge what a huge component aesthetics is. But when people use the word cool around computer programs, they're talking about aesthetics. It's an aesthetic response. So the response to the character set and the notation, I think, is entirely valid. You see something like the circle overstruck with a style, and know that that means both rotate and reverse in APL. It's something inside you just melts and goes, wow. And if you use other languages, as so many of us have to do, and you write things like reverse, or you invoke an array method to blah, blah, blah. So every time you do it and you know it's going to work, you just want to cry.
Yeah, I think I've mentioned a couple times on this podcast and others that I haven't actually even known the meaning of the glyphs for months when using them. And then every once in a while, I will stumble across some blog that, just nonchalantly mentions, and if you, once you recognize that, what Steven Taylor just said about the reverse, that it's reversible, it's like you almost fall off your chair. Like, I think I've said that, for a long time, I thought tally was a really bad sort of glyph until you realize that it was a composition of, the equal underbars and slash. And it was, if you rotate it 90 degrees, it sort of looks like you're keeping track. And it's, as soon as you realize these things, like there's so many, I'm not sure if we have like a link to a collection of all the different, stories or meanings, the spool of thread with Ravel and the power, from Roger Huey's favorite one of the log. Like there's so much of this stuff. And I mean, I feel like we have the exact same, well, not the exact same comment, but our last guest, Vanessa McHale, who's primarily a Haskell and J programmer, was mentioning that, the ability to express yourself so succinctly is a part of the power of the language. And it's the spelling being one or two characters for each of these operations. And I think I even commented that, like, I feel like that's, it's like, you shouldn't say that as one of the top things, but really it sounds trivial, but it is actually extremely important and completely changes the way that we use these languages and that we think about solving these problems in these languages.
Oh yeah, the combination of the interactivity, the what's the word, the way, well, the fact that a sequence of operations can express a single thought. We always mention that about APL. You're not breaking a thought up into multiple lines because the syntax forces you to do that. So you can write, and of course, this is a feature that is sometimes overused, often overused, especially by beginners who are impressed with the fact that you can write 200 characters in a row and it'll process along the way and give you the result you're looking for at the end. But that feature, what do we call that? The idea that you can express a single thought in a single syntactic object. I don't know what that.
Concatenative programming?
I'm not sure. I don't know. I don't know if there is a term for it. But all of these features work together, I think, to make the languages so attractive. I think APL and J programmers are much more aware of this than K programmers. I think that there's a higher degree of sensitivity to these features in J and APL than in K, but that's just an impression.
Do you think there's a reason for that? Like, I actually haven't fully learned the beauty of J in that the dot and the colon represent sort of like two characters or two categories of different things, similar to how in APL, like, the double dot each, when that's sort of composed with some other operation, it typically means an operator or something like that. Is it because of that? Like, I don't know enough about K to know, like, if that's something that K doesn't do as much. or what gives you the impression that sort of J and APL programmers like?
I think J programmers are required to have a more systematic understanding of the structure of the language, the different categories, as you say, in order to be good at it. K programmers can hack pretty, I'm not suggesting that we all do, but we can. So it isn't really necessary to understand the yeah, I'm not actually sure. It's just an impression I have, because I don't write J. I don't speak J. And it's been years since I've done any APL.
So do you think it might be because J and to some extent APL as well? I'm not sure how much K has the things like forks or trains or those kind of things where you're actually thinking about combinators. Is it more linear than J?
Well, there's a limited number of adverbs in K, right? There's only 6. Over, scan, prior, each right, and each left. And each right and each left are kind of dispensable, although you wouldn't want to dispense with them. They're extremely useful. So and you've only got 3 categories. You've got nouns, verbs, and adverbs. J has, I'm not even sure at this point how many other categories it has. I know it's conjunctions, which we don't have in K, and just it's a larger language, much larger language than K.
So hold on, what do you call the category in K of I don't know how to speak about them. $, question mark, @, and dot. They're not adverbs, not verbs, and not nouns, right?
They're verbs. Yeah, they're verbs. They're verbs, but of course, they are like dot, for example, has their is monadic dot, dyadic dot, and then there's a version of dot with 3 arguments and a version of dot with 4 arguments. And I think there may even be a 5th argument, but I can't remember. I never use it. So are they verbs? Well, this is something, Stevan, you might want to address. The distinction between a verb and a function. My understanding is, and the way I use it, a verb is a syntactic concept, and a function is a semantic concept. So verbs represent functions, but there's a distinction, right? Do you want to elaborate on this, Stevan?
Well, I do a little bit, because one of the first things I got assigned to do when I was the KX librarian was to clean up the terminology for that, because a lot of people with much less experience than you were very confused about what it was. And a little inquiry revealed that some of our most experienced Q programmers not only couldn't give a plausible definition of what an adverb was in Q, they couldn't give it in English either. So a metaphor, an isomorphism, which I think had served Ken Iverson very well. And I'd noticed that Canadians of a certain generation seem to be extremely well educated about English grammar. They know about concepts in English grammar that, although I'm a fluent speaker and writer of English, I don't know these terms. I think the concept of the isomorphism of the noun, verb, adverb, which had been useful to that generation, was no longer really helping anybody. So at my boss's insistence, we turned the word operator for what people commonly call operators in programming languages. Function, now in talking about Q, refers to operators and lambdas and keywords, anything that takes arguments. Verb, I never satisfied myself that everybody who was using those terms previously were using them the same way.
have nothing really to add to that, except it's always seemed pretty obvious to me that noun, verb, and adverb, as I say, are syntactic concepts. So A plus B as an expression has two nouns and a verb. But the actually in K, this actually makes it, I think, more clear. I don't know if there's anything parallel to this in APL or J, but in K, if you want to capture plus, you want to assign a name to it, you can say A gets plus, or you can say A gets paren plus paren, and that nominalizes the verb. It turns it into a function. If you look at the type of paren plus paren in K3, it's 7, which is, I'm sorry, it's 7, which is the type of a lambda as well. So and in Q, I think you can Q, yes, you can capture, or K4, you can capture, you can nominalize adverbs as well, right? Paren slash paren is a I don't know what the type, I can't remember what the type system is in Q, but so that seems pretty clear. I don't think there's a lot of confusion about that. Whether people will pick it up and use that distinction is a different question.
Well, it brings me to a question I've been wanting to ask you for some time. When we were talking before we started recording, you mentioned Raymond Smullyan's work. And he's a notorious Taoist as well as mathematician. I converted as a young man to Buddhism. I was raised Congregationalist before that, but in between, I was a humanist for a while. So I've sometimes described myself as a lapsed atheist. And I think from what you're telling us that it'd be fair to describe you as a lapsed Q programmer. You've
That's true.
fallen back onto K, and that makes you a member of a very small community of people who know both languages. I don't count myself among them. The official position on K4 is that it's an implementation language. It's not documented. It's not supported, and we don't encourage people to use it. So personally, I don't have much experience, and I'm wondering what you could tell us about what you see of the relationship between the two languages.
Oh, I only have room in my head for one language at a time. So actually, a couple of months ago, I tried to implement a Tableau system. I was talking about this earlier, a Tableau system in Q, and things just kept falling over, and I realized that and of course my APL skills are incredibly rusty. I'm always amazed at people who are capable of keeping more than one language in their head at the same time and being fluent in more than one language. Maybe some of you are. It sounds like Connor, and you're a polyglot. Very impressive. I don't know how you do it. So let's see. Well, Q, and I was a Q programmer for 6 or 7 years when I was at Millennium Partners, a hedge fund, and we used Q extensively. We didn't use K4 at all, although you could obviously exit into K4. The decision at Millennium was we were going to use Q, and it's a good decision. So what's the difference? K3 obviously lacks some really wonderful ideas that only appeared first in K4. Table data types, transparent dictionaries, you could add dictionaries together. In K3, let's point out, in K3, there are ints, floats, symbols, characters. Okay, good. There are lambdas. There are dictionaries, but dictionaries are atomic. So you can bang a dictionary to get its domain. You can get its value by saying dictionary bracket bracket. So you can take a dictionary apart, operate on it, put it back together, which is sort of like enclose disclose in APL. And we, as K programmers for years said, take it for granted that you could do that, and that's the way you had to deal with dictionaries. The atomicity of dictionaries was taken for granted. So in K4, when dictionaries became permeable, and it was, wow, this is fantastic. This is tremendously liberating, and it is. It's a wonderful idea. The idea that you could flip a dictionary is that right? You can do that, right? Flip of a dictionary gives you a table, right?
If the values in the dictionary are the same length. Yeah,
so that was wonderful. It's a wonderful idea that you could do that. And the fluidity of programming, the flow is a concept that I was looking for before. That program flow. People talk about this all the time. How programmers will enter a kind of mental space where ideas just flow, and Arthur talks about it a lot. So these features certainly contributed to increased flow, as does the table dictionary, that you're going to distinguish a dictionary of vectors or dictionary of lists from a table. And that was, and of course the fact that tables are lists, not dictionaries. So really, and so from my point of view, the K4 rationalized a whole set of ideas. I never saw them as limiting in K3, because of course when you work in a programming language, it's a kind of you become, or at least some of us, you become ideologically blinded, and the limits of the language are the limits of our world, to quote the greatest programmer of the 20th century. Yeah, okay. So so it was a revelation to encounter Q after years of working in K3. I'm trying to remember if this was a conversation that I had when Arthur was developing Q. I think it was Q. Yeah, it was Q. He was living in Florida, and I went to visit for a while, and we had a conversation on the beach where we were talking about dictionaries as mappings, as maps. So mapping, a domain of, I think in K4 he only allows symbols, right? You can't use anything but symbols for dictionaries. Am I right, Steven?
I that you can use anything as the key, but it's most common to use symbols.
Oh, is it generalized? I can't remember. So yeah, so I think K4 or Q represents a significant conceptual and practical evolution from K3. Nevertheless, I think there are some rough edges in Q. I, and some of them have to do with the Q dialect, and some of them I think are intrinsic to K4, but I don't remember what they are. So, and K3 is a smaller, tighter, more regular language, I believe. So the limitations. So I think once you remove the limitations on a concept, you're obligated. You incur an obligation to have that feature generalized completely generalized. If there are arbitrary limitations, if you've got some, I'm being very schematic here, but if you introduce some feature and you don't, and you have, but there's a footnote. You can't do this, and you can't do that, and you can't do this, right? Then you think, whoa, wait a minute, wait a minute. You haven't thought this all the way through. So it may be really useful, but you got to learn the limitations, which is why Q for Mortals is this thick, and Don Orth's K3 reference manual is this thick.
For our listener who can't see the width between the fingers, the Q for Mortals is about 5 times as thick. It seems like, from what I can tell by the finger lengths.
It's a lot long. Well, yeah, and it has to be. It has to be. There's just a lot. It's a much bigger language. Look, the the 2 most frequent dog-eared sections in my copy of Q for Mortals are the page on types and the page on the functional forms for the various KDB operators like select and so forth. So those are really dog-eared because I can't remember that stuff. Yeah, I think that's another important point that I'm sure, have you all seen the K3 reference card? The little accordion card that we developed at UBS. Steven's going to go grab it right now. So the entire language, can be put on this little tiny reference card, and it is complete. There's nothing missing. Yeah, there it is. So, K programmers don't frequently, they don't consult any reference material, reference manual, user manual. You learn the language, it's small enough, you get it all into your head and you use it. And I think that's great. And I think that's also true for a lot of Q programmers. Was that? Oh, it's the K3 reference manual. Yes.
Yeah, K language summary, which fits on what looks just sort of slightly bigger than an index card.
Now, I think in subsequent versions of the language, like K9, Arthur has taken K3 as his model and not K4. And yet the K9 is more general than the last iteration I've seen of K9, which is several months ago, more general than K4. So anyway, I guess when we're done with this discussion, I'm sure I'll think of like 8 different other things that have to do with the differences between the variants, the flavors of K. And those are the ones that strike me. And of course, K4 is a much more K4. A lot of it has to do with the applications that people are writing. We at Millennium Partners, we did not use Q as a database language. We didn't use. We wrote a distributed P&L system. That was the primary application, and the data was not in. It didn't use the. I can't even remember the tools that people use in KDB Plus for HDB and so forth. We didn't have anything to do with that. So, and we wrote a GUI for this application. So, but that was really an idiosyncratic use of KDB Plus or of Q. I think. I don't know. I don't know what the Steven, you're in a much better position than I am to talk about the space, the application space for K4.
Well, I think it's very much undervalued as a general purpose programming language. Some of the reasons for that are obvious. It's proprietary. You can't just download it and use it for free as a general thing. There are free versions of it around. Most people who would encounter it in fintech large data applications. So there's this huge skew in the application space. But this morning I was writing Q to clean up metadata on my Apple Music library. Part of an exercise to demonstrate this is a really excellent language for hacking.
So as a K programmer, I mean, I think one of the most beautiful uses of an array language is John Scholl's Game of Life video on YouTube. And I can't tell you how many times I've watched it. And I watch it for, I just find it incredibly pleasurable to watch it. It's to me, it's the most perfect example of the use of array language, a language to solve a problem. It's like a short story, you know. You agree? And his work as the dynamic functionista, which is again in an area that greatly interests me, which is combinator theory, is miraculous. And I did my best to implement a functional programming language which compiles into Curry combinators. And then I looked at his work and I said, okay, either or both of the following is true. John Scholes is much smarter than I am. An APL is much more expressive than K. So that was my impression. I still believe both of those propositions. So are you guys familiar with this work? Have you looked at it? It's magnificent. It's magnificent. It's just so wonderful. I haven't looked at it now in a couple of years. I don't know where it is on the Dialogue website. He was working. This is when he was the dynamic functionista. Does this ring a bell for anybody?
Yeah, I mean, we'll include a link to it. There's a whole article on the APL wiki about that video.
Not just the Game of Life video, but the code that John wrote on combinator, functional languages and combinators. So magnificent.
Well, there's lots of things on there's a defense website that has.
Yeah, I will have to track this down because I have not stumbled across this yet, and I actually like my I'd say 100%, 80% of my free time I've spent over the last 2 months to 6 months tracking down the history and lineage of combinators. And I think it's probably one of the least well acknowledged, although it's clearly I had no clue that John Scholes was doing this, so he's clearly done some work. And you said yourself you tried to write a functional language that compiled down to the Curry combinators, which is both of Miranda, Sassel, and KRC are 3 different languages that do that. Those are all David Turner's languages.
Yes. Yes, exactly. And this is not an area of special expertise for me. It was you guys must be familiar with this, that if you want to learn something that's in any way related to, you're always looking for opportunities to learn by coding. So some people learn differently. They learn very abstractly. And I'm not one of those people. And I learned that's an NSL as kind of a record of things that I wanted to understand better. So I implemented them. And I'm not sure it did increase my understanding all that much, although it was very satisfying to do the implementation. And so I actually first learned something about curry combinators from a talk that Raymond Smolian gave at a colloquium at Princeton when I was a student, in which he talked about, I mean, you're probably familiar with his analogy, the mockingbird. Yes, exactly. His birds and combinator birds, which is, quintessentially Smolian. It's just kind of playful and very profound way of understanding things.
Yeah, no, I think yeah, it's a shame in one sense that Iverson and Eugene McDonald published a paper in 1989 called Phrasal Forms.
Really?
And
look at this.
That is basically the only literature that I can find that links combinatory logic and the Curry combinators to array languages. Because from there, Iverson goes on to basically rebrand combinators as trains. And he calls the S combinator the hook and the phi combinator the fork. And then since then, it's sort of the relationship between array languages and combinatory logic has been basically, the link is implicitly there, but just not acknowledged. And I think that at least APL and J, I can't speak as much to K and Q because I haven't spent enough time with the languages, but I think they're the best languages in the world for doing combinator programming. I don't think there's a programming language out there. There are other programming languages that compile down to combinators, but in terms of languages that actually have support in the forms of functions or glyphs or what have you, I think like array languages should be rebranded like modern combinator array languages because they have such good support for it. So yeah, we're going to have to go, and I know that Adam has just linked something to track down this work and writing by John Scholes, because I know that he was definitely involved in adding some of the combinators to Dialog APL in the last 2 decades or so when they started adding them. But I'm not sure, Adam, if you have more info.
He was, interesting enough, Dialog is the only APL that with long history that has had the JUT as a proper operator. So that's a combinator, right? And I wouldn't be surprised if it was John Scholes who had that pushed for that to be part of the core language right from the beginning. And that combinator allows you to express most things.
How does it work, Adam?
But that's the one that it is two different things, right? If you give it if the derived function, so f jot d g is monadic, then it's just I think it's the B combinator, just to apply one after another. And if it's a dyadic function, then it's the left function f that's dyadic, but with the right argument pre-processed by a monadic application of the right function. So
is it used in your experience? Do people exploit this combinator in their code, or is it relatively esoteric?
Yes and no. I think it's not well understood what exactly how important it is. I think that's a problem. I think people use it for some simplistic things and then don't realize how it's fundamental to combinatorial logic. So it's a decombinator when it's the dyadic one. And the fact that you can express things just by composing more and more using the decombinator. It might not look pretty in the end, but using the decombinator, so this, and it was originally in Dialog APL, it was just called compose. right? Not a specific type of combination. It was recently renamed because we're adding so many other combinatorial operators. It's called function composition operators, and then it renamed it. But it was just called compose because you can build up every type of composition from this.
I need to take a look at this.
At least a magnetic thing.
A thought occurred to me as you were talking. This is especially true, I think, for our array languages. You have some operator that appears kind of mysterious. And are you drawn to finding uses for it in order to find out exactly what it does and what its limits are and how you can...
I think it goes both ways. I mean, but as I mentioned, that I think it's often misunderstood. I think people have kind of simplistic need, and then for this particular operator, they'll try to use it, and then it works in some cases. In other cases, they just burn themselves and they're like, oh, this didn't do what I expected to. Go to something else, or write it as explicit code. It's not in a tacit form. And it took, for me personally, a very long time before I realized, oh, that's what it does. It's the same as the left function, but it pre-processes the right argument with some other function, which means that together with the other operator that's in many modern APLs of commute or swap, swaps the arguments around, being that it can pre-process the right argument, and you can swap arguments around. That means you can also pre-process the left one. You just need to swap it over to the right, pre-process, and you can swap it back again.
Yeah.
And so by swapping and swapping, you can move things in and out and select parts of an argument and swap around and apply things, and you can build everything up for that. Once I realized that that's all it does. It's just pre-process right. That's a long name for it. Very good. Then I started seeing patterns where I would use it. It's not that I looked at the documentation and said, oh, that's what it does, and I need to understand, and then I should try using it. I need to understand what is the concept, the thought concept, right? It's notation for thought. That when I have that pattern in mind, then I have that in my vocabulary and go say, oh, this is exactly what I need, and now I've started using it. So it took years.
Yeah, it's fascinating, Stevan. Are you? When I listen to Adam talk so blithely about a commute operator, the K, in limiting itself to single character operators, forecloses on the possibility of having an expansion of primitives. You cannot fit any more primitive operations into this very limited space, very limited syntactic space. So I would love a commute operator, but there's no room for it in K. And there's no room for the kind of combinators that you describe. So K, especially K3, is a much smaller language with well-defined limits.
Well, you could write a commute operator, right? Earlier APLs and some APLs don't have a commute operator. You can write it yourself. I often find it limiting in when I have a look at K. It's rare. I'm definitely not an expert or even less than a newbie. And I can't define my own inline functions, verbs, and you can't.
Sure you can. Oh,
No.
I see what you mean. You mean write them in fix. Write them in fix.
And
right.
I can, and
yes.
Similarly, I can't really write something that behaves like an adverb. Yeah, I can write a function that takes multiple arguments, of which some of them might be functions, and I can write a formula in there. But then, in my opinion, or my mind is so limited in its in ability to remember where I'm holding, that when I need to put brackets around the arguments and jump back and forth, and things aren't right next to each other, then I can't keep track anymore.
That's right.
It's I people probably by now know me for hating parentheses, because I need to have a mental stack whenever I see a parenthesis. I come from the right, and now I'm concatenating, and that's opening parentheses. Now I need to remember what am I concatenating to the right. I might evaluate something on the left before I can concatenate it. I can't handle that. And that I'm missing. So you can write a commute operator, right? It's easy to write in K, but it will
Well, yes, of course, yes, of course, it is. It's easy to write, but then, as you point out, you're you're coding. You're not using the primitives. And I meant that, you know, it's one of the advantages of having this kind of unlimited uh, space that the APL character set and any variations that, any kind of combinations of overstrikes can give you. Um, it's a uh, it's a lot of power. It's a great deal of power. Um,
With that comes great
it
responsibility, right?
I was trying to think of how to complete that, but it certainly imposes a it imposes a demand on the programmer. At least it would on me, to say I have to master it all. I have to learn this entire language in order to write good code. I would be terrified if I only understood a part of the language. I'd think, am I really doing this the best way? Is this the most efficient way to do it? And and one rarely, I think, rarely feels that way in K. It often feels that you've got the best possible solution, or one that's closest to the best possible solution. Here's an anecdote. I know you guys are not. Well, Stevan, you'll, as a K programmer, you'll get this. This happened pretty early on at UBS in the development of K. Um, Arthur, who was in the next office, came running into my office, and he said, "Look what I found!" uh, and he found that you could define a lambda that consisted only of x, y, z, x, where x, y, and z were the default arguments to the function. So it was a triadic function. And x, y, z, x over turned out to be uh, a way to write converging selection on a table, and at the same time multi-column sorting on a table. So there's this function x, y, z, x, and it does these two completely, or it seemed apparently totally different things. And I think that's one of the beauties of K, at any rate, that that very short and simple um, functions or expressions. I'm not expressing this well. One hopes that one will discover some unexpected, uh, some unexpected piece of, some unexpected property of the language, that some very small bit of code will do something entirely unexpected, but interesting and useful. And I think that's one thing. The other thing, and I've speculated about this, and I don't again, I don't know exactly how to express it, but if you consider, I'll speak very loosely. If you consider all of the short, syntactically valid sequences in any of these Iverson languages, code sequences, sequences of length 1, 2, 3, 4, 5, 6, 7. Consider all the syntactically valid sequences. How much I would expect that to be a very dense in that you'd find a lot of really useful and interesting functions in that set, supplied with correct arguments, of course. And I've often wondered how much was there waiting to be discovered that that we don't, we wouldn't anticipate. We wouldn't say, oh, these 5 characters given these arguments will do this function that up till now I've been, writing much, writing a lot more code to do. So that's, that's of interest to me.
My father told me that early on in APL days, conferences and other APL events, or maybe it was even in various newsletters, they would explore the dot operator in APL, the inner product, and say like there are all these dyadic functions, and this you combine two of them with the dot operator. What does this do?
That's it. Yes, exactly. Exactly.
Bob, were you going to say something?
Well, I was going to say that I think sometimes the magic happens when you get something like that in the language, and it's actually not just something that you didn't know the language could do, but it illuminates the way something else works. So when you didn't think two things were related, suddenly you realize they are related, and now you have a whole different viewpoint of what you're doing with it. And it's the language that's introduced that kind of a dual view of it. And to me, whenever that happens, that's like a put my pencil down, go for a walk and come back again, because it's just, whoa, too much.
So perhaps the highly discredited Sapir-Whorf hypothesis, which doesn't apply to natural languages, applies to programming languages, in that it conditions the way we think and how we think. Well, maybe that is, I think that's largely true.
Yeah, I certainly find it true that I do find my language limits my ability to come up with concepts. And I mean, in the last couple of years, what I've worked on more is trying to work beyond a language. So I'm thinking more about things that are not expressible by language. And that's a very challenging but liberating thing to get into. If you
Oh wait, now could you say that again? You're thinking about what, translinguistic concepts or translinguistic ideas?
Yeah, it's sort of more in the realm of meditation. You start thinking about a tone, because you can't express a tone with language. And you focus on the tone, and then you try and think about how you're experiencing a tone without language. And it starts to open up what language is actually limiting you to, because you're now thinking about something that can't be expressed with language.
It reminded me, a friend of mine, Aaron Siegel, who teaches philosophy at Hebrew University in Jerusalem, is this semester he has a seminar on ineffability, which strikes me as something right up your alley. You know, the territory of meaning that goes, that's inexpressible. And as a Taoist, I'm sure Stevan is conversant with this idea.
But weren't you saying that it's only not expressible in our normal human languages, whereas you can express a tone that cannot be written, and you can possibly express something in an array language that cannot otherwise be pronounced?
A tone is are you by tone you mean a musical tone, Bob?
Yeah, a tone or a frequency. I mean, it doesn't have to be musical. Mm-hmm. It's something that would not normally be expressible. Like, you express it, how you experience it is, you listen to a musical tone. That's the experience of it. You don't describe it usually in terms of language to experience it.
I think of two composers, Scriabin and Messiaen, who were reported, tones, notes having color or being colored, and I don't experience that. That's not, the mapping from one sensory domain to another. It's not.
But you probably experienced it as a visual artist.
Relationship between musical tones and.
No, I'm thinking more in terms of when you were a visual artist, there were things that were beyond what you would be expressing with language, because you were expressing visually. Yeah.
Oh, sure. Oh, yeah. Absolutely. I didn't think of them as ideas or concepts. Not because I find the idea of an inexpressible concept to be a contradiction in terms. Concepts are intrinsically linguistic, or at least capable of linguistic language, expressions, concepts. But there are other non-conceptual cognitive entities, I guess you'd call them, that feelings, for example. A feeling isn't a concept, and so that's. But if it's conceptual, it's expressible. I don't know what it would mean to have an inexpressible concept.
The game I usually play is on the boundaries of things. So I think you're right. I think by the time you've got a concept, you've got something that's expressible in language. But I like to go to the edge of that and find out what's there.
Yeah, it's.
Yeah, I find it interesting. I'm not sure whether our listeners will.
That's very interesting. I think this all goes quite beyond. Although this is what array programmers think. Actually,
exactly.
Arthur.
This is what array programming feels
Yeah,
like.
Arthur Whitney used to say that our languages are so productive that we array programmers have lots of time to waste on other things. So.
This conversation is reminding me of an interview with a Swedish poet, Åsa Beer, who at one point in the interview says, forget about your readers, forget about self-expression. It sounds so much better in Swedish. Skit på läsarna. Skit. Poetry is research into the unfathomable.
I like that. I like that.
And it enables us to make connections in the way that we were talking about. Well, we hadn't seen connections before. And I guess it's why Shelley called poets the unacknowledged legislators of the world. So this is really a stretch. I'm reaching out for connections which may not exist. Stevan, I know you're or at any rate for some time were very keen on Krav Maga. And I'm wondering if there's anything in your experience of Krav Maga that you relate to programming in K.
Only that martial arts allows one to forget for a moment, or more than a moment, about programming and philosophy, and that's. I mean, as a very much an amateur. I mean, just not as the worst student in my class, I will say. I just forget about, turn off the mind, which is it's a good habit to get into, isn't it?
Sounds like flow.
It is a kind of flow. Oh, it's absolutely a kind of flow. Well, I think sparring and grappling, which I was terrible at. But that, yes, definitely, that's all about flow. All about flow. So flow is good. We like flow. We like flow as programmers. We like flow in all aspects of our lives. Whatever, it's a very general concept where you're just totally identified with the activity you're engaged in, and you disappear. You disappear. There's only the activity. You are the activity. So it leads me to wonder whether there's value in the opposite. Value in not achieving flow. And I think there probably is. I think
I think there definitely is, because I think that's where flow is when you've reached that state where your practice is internalized, and you're just expressing as it comes out. But I think to get there, you have to have broken it down, and I think you have to get away from flow to break something down.
This is a very good insight. I like this a lot, and I think it does describe. Exactly. It's exactly right. Thank you. That's good.
I fluked it.
Well, I like that. Yeah, teaching is the complement of flow.
Okay.
The obverse, yeah.
And it involves struggle and failure and all right.
Yeah. Because we all know people who seem to be naturally good at one thing or another, and as a consequence, are utterly unable to teach to anyone else.
That is, yes. Yeah, I keep saying that. Yes. I like this conversation. This is very good.
Well, I'll say, because we have flown by the hour mark, and this has been, you mentioned, I think it was a couple minutes ago, turning off the mind or something, and this conversation has done the exact opposite of that. My mind is exploding right now.
Well, I'm so glad to have met, and of course I know Steven. I'm so glad to have met the three of you, and I hope we can continue to talk and engage and exchange ideas.
Yeah, you will have to promise to come back on, because I feel like we haven't even really talked about all the different projects on the site. I mean, you have a whole, like, longer than 30 years, but, starting from sort of when you met Arthur Whitney, I'm guessing that was sometime in the 80s and
That's
A+.
about right. Yeah.
But you have this journey from APL to A+ to K to Q back to K, or I'm not sure if, yeah, no, that's right, K3. And so, yeah, you have a very, I mean, I think the array language path is not as commonly traveled. It's a seldom traveled path these days by sort of people picking up programming languages. But in terms of those that have over the last few decades, you have a very, very unique path. And I'm not sure how many folks are able to tell stories about going to visit Arthur Whitney on the beach in Florida, and yeah, I'm very jealous. Yeah, so you'll have to promise to come back, because I still have a billion questions, and I'm going to be going and researching everything I can now about John Scholes. And your Curry Combinator language, was that just a project, or can that be found on your website as well? Or
Yeah, it's on my website. It's called Slack. It's Steve's Lazy Combinator K. Is that right? Steve's Lazy Combinator K. And it's an implementation of, I can't remember there's lots of stuff in that domain. There's Slack, there's a whole bunch of other stuff on combinators. Yeah, so you'll find it all there. And it's unfortunate in a way that it's all written in K3, although I have a K3 interpreter for Windows and one for Mac. If you're interested, you can get that from me.
Yeah, this sounds like, I mean, I've been trying to simultaneously learn APL, J, and BQN, and K is just, it's been at the edge, but now I guess I have motivation to go and learn this as the fourth one. I have this is, I don't think I've mentioned this before, but one of my goals over the next 2 years is to write a multi-directional transpiler between all three dialects. I'm not sure how easy it would be for K, but the idea is that you write APL or BQN.
Wow.
And it will simultaneously like write the equivalent expression. Like, it'll be limited because obviously they're not isomorphic.
That's an interesting idea. That's a real interesting idea.
But like, it would be, at least for me, an incredibly useful teaching tool that, like, if you did it correctly and just start with a few small expressions, you could just write once in APL or BQN, and then what I might not actually be able to know how to write easily in J, if I get the Lego components correct, I can just write it in APL and then see the equivalent. And if I open source it, then, a bunch of, actual J experts and BQN experts could go and, because it'd probably just be some dictionary lookup thing. And so if there's nicer ways to do something in J that I'm naively converting from APL to J, Bob could come along and be like, oh no, actually this is the idiomatic way. And it's like a kind of a pipe dream project, but the point here being is that now K clearly has to be added because I need to go.
It sounds like a very big
Yeah, it would be.
project.
I mean, conversations like these, I don't usually say this on air because, you know, my employer might be listening, but like whenever I have these types of conversations, I always tell myself, you know, I should just go quit my job and just study for 2 years because like clearly like I'm wasting my time working when I should be learning. But you know, life requires being able to pay for stuff. So we'll wrap things up by just saying once again, yeah, thank you so much, Stevan Apter, for coming on. This was, like I said, this is like a better than a Marvel movie, and I love Marvel movies, but this is
Great pleasure for me. Thank you for inviting me. I really enjoyed myself.
Yeah, we look forward to having you back at some point in the future. And with that, we will say happy array programming.
Happy
Happy
array
array
programming.
programming.